Welcome to the Basic Logic YouTube lecture series. This is lecture number 3. I'm your instructor, Nick McGinnis. Let's get started. Today we're going to be talking about truth functional semantics. What does that mean? Well, way back in chapter 1, we introduced a number of logical properties sentences might have. And in this lecture, we're going to review these properties and present their truth functional counterparts. The idea is to define logical properties purely in terms of the truth conditions of expressions in sentential logic. Now, what were those properties? We had logical truth, logical falsity, logical indeterminacy, logical consistency, logical equivalence, and finally deductive validity. Now, the first three are properties of individual sentences. And the next three are properties of sets or groups of sentences. Though, in the case of consistency, it makes sense to think of a group made up of only one member. So by group, I mean one or more. Whereas in the case of logical truth, falsity, and indeterminacy, only a sentence is logically true or logically false or logically indeterminate. Now, the sentences that can be judged true or false, unlike, say, questions which have no truth value, the vast majority require some knowledge of the world to determine whether they are, in fact, true or false. Now, imagine I say French is my mother tongue. This is either true or false, but which is it? You need to know some facts about my upbringing to answer. Sentences that require this kind of background knowledge about the world are indeterminate, because they could be either true or false, and you need to know something about the world to determine that. Now, logically true and logically false sentences are different. We don't need to know anything at all to realize that they are, in fact, true or false. For example, if I say to you that, look, either French is my mother tongue or it isn't, you don't need to know anything about me to know this is true. Either it is or it ain't. We don't need to know anything because the sentence is uninformative. It's compatible with any set of facts, with any way the world might be. So it's a logically true sentence. Now, logically false sentences are similar, that we don't need to know anything about the world to realize that they must be false because they're contradictions. They're impossible sentences, a description of a state of affairs that cannot possibly be. If I say that French is my mother tongue and also French is definitely not my mother tongue, then if you take it literally, it's obvious that I'm saying something false. After all, which is it? I'm contradicting myself by saying that something both is and is not. The sentence is logically false. It's not compatible with any way the world might be. Now, these logical concepts are actually independent of the particular system we're now using, which is sentential logic. Nevertheless, we can give truth-functional definitions of these concepts that operate exclusively within the confines of our system. And that's kind of neat. This is the semantics of Sl. Now, semantics is to be contrasted with syntax. Syntax has to do with the rules for producing grammatical expressions of Sl. It tells us why P and bracket Q or R is well-formed, but P or Q and R isn't well-formed. Semantics has to do with the truth conditions of sentences, their truth tables and how they are built, which determines the meaning of well-formed expressions. Okay, so let's start with truth functional truth, which is the counterpart to logical truth in Sl. A truth functionally true expression of Sl is simply one whose main logical operator is always true. Or as the textbook puts it, a sentence P is truth functionally true if and only if P is true on every truth value assignment. What does that mean? Let's look at an example. So this expression here is truth functionally true. If you look at the main logical operator here, you see a nice column of T's. So no matter the truth values of A and B, it's true or false, no matter the values, the full expression is always true. This is the important part. It doesn't matter what the truth values of its components are. The expression as a whole is always true. This is why it's uninformative. It's true no matter what. We have this big column of T's, true no matter what the circumstance. And this sentence is truth functionally false. Once again, no matter what the truth values of A and B are, the whole expression is always false. It doesn't matter how the world is, whatever A and B stand for, whether they're true or false themselves, the expression as a whole is a contradiction and thus always false. Truth functionally indeterminate sentences are the ones that are neither truth functionally true or false. They have a mixture of T's and F's under their main logical operator depending on the values of the things they connect. Okay, what about consistency, equivalence, and validity? Logical consistency asks whether a group of sentences can all be true at the same time. Now, for example, imagine I say the following three statements. First statement, if it's raining, I will take the bus. Second statement, it is raining. Third statement, I'm not taking the bus. Well, one of these things is false. Look, if the first two are true, the last one must be false. If I'm saying, if it's raining, I'll take the bus, and it is raining, then that implies that I'm taking the bus. If the last two are true, the first must be false. Right? We can look at this property in truth functional terms rather easily and see why one of these sentences has to be false. So let's look at the paraphrase. If R, then B, R, not B. If rain, then bus, rain, not bus. So truth functional consistency asks, is there at least one truth value assignment where these three sentences are all true? Right? Is there at least one truth value assignment, one row, where these three sentences are all true? If not, the group is inconsistent. They can't all be true. So let's look at the rows here. We have true, true, false, false, true, 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 false, false, true, false, true. Oh my God, they are inconsistent. There is no truth value assignment under which all three sentences are true simultaneously. So the set is inconsistent. It's easy to see why. If it's true that R implies B and it's true that R, then B should be true. But we're asserting that B is false, so one of these has got to go. Now, logical equivalence is basically about synonymy, though we're going to define it this way. Two sentences are logically equivalent if it is not possible for one to be true while the other is false. Note this means all logically true and false sentences are equivalent to each other, so be careful not to overthink the analogy to synonyms. But in any event, the truth functional counterpart is pretty obvious. Two expressions are truth functionally equivalent if and only if they have the same truth table. So consider the following two sentences, if P then Q and either not P or Q. As you can see, their truth tables are identical, so the two sentences are truth functionally equivalent. And remember that the column we're supposed to look at is always the main logical operator. The main logical operator here is the if, true, false, true, true, and here the main logical operator is the or. If there were brackets, it would be the not, but there are no brackets, so the main logical operator is the or, and we see true, false, true, true. So if P then Q is equivalent to either not P or Q. Finally, there's validity. An argument is valid if and only if it's not possible for the premises to be true and the conclusion false. Right? This is probably the most important definition in the whole class. An argument is valid if and only if it's not possible for the premises to be true and the conclusion false. Now, the truth functional counterpart is really simple. An argument of SL is truth functionally valid if and only if there's no truth value assignment where all the premises are true and the conclusion is false. Let's look at an example. Maybe it'll make it clear. So we have a valid argument. If P then Q, P, therefore Q. So if the argument is valid, we should see no row where all the premises are true and the conclusion is false. So let's check the rows. Oh, true, 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 false, true, false, true, false, true, false, false, false. And what we're looking for is one situation where all the premises are true but the conclusion is false. But there is no assignment. There is no row where all the premises are true and the conclusion is false. So the argument is valid after all. So these are the truth functional properties, and which are kind of the SL equivalents of the logical properties. In the next lecture, what we're going to do is interdefine these with consistency, because this is going to be important when we get to truth trees, which is a method of verifying the properties of groups of sentences. So until next time, take it easy.